All right, so we're going to hook up with the next one, which is 232, causes of mass movement. And for this one, it's pretty cool because there is a really good professor out of Tulane, Professor Stephen A. Nelson, who went over mass wasting processes, which is basically what we're talking about here. So in this website, all the stuff from Cambridge he covers. We're going to be looking at flows and slides, landslides, earth slumps, rotational slumping, soil creep, solid fluxion, and mud flows. All right. So if we look at mass movement, we know that mass movement is the downslope of movement of rock near the Earth's surface, and you can read about that. You see a bunch of different ones here. We're going to be talking, though, here about the different types of mass movement. So we've got two different main types. We've got the slope failures, which are going to be a failure of the slope, resulting in transfer of debris down a hill by sliding, rolling, falling, or slumping, and sediment flows, which is when it's mixed with water or air and actually flows. Slope failure, the rotational slide is going to be like your, basically where the you have a slump that is a downward rotation of the rock. A regolith occurs down a side of a, basically like you can see like what happened here is you have these slumps that just kind of like fall down. They leave scars or depressions in the hill slope, and oftentimes these do happen because of human activity. And so there will be like, you know, if you go up north and you go like around a mountain and you go, and it's like, oh, it's cool, it's flat on the mountain. Well, that's because they like carved it out into the mountain and made it flat. I mean, it was angled at one point. It's not just like these roads are there. They carved them in. This can happen. This can really, lead to the rotational slide slumps. Rock falls, they occur when rock falls. I mean, basically that's what it says there, right? So the debris and the rock fall down a slope. If something becomes like you see this rock that was up here, it became dislodged, falls down to the bottom, can form those talus piles that we talked about before. So it could be a single rock or a bunch of rocks and all that kind of stuff. All right. Slides. They happen when rocks or debris slide down a pre-existing surface, some kind of surface that happens in there, and then again this can form piles of talus at the bottom. So unlike the rock fall, which basically falls down off the top of something, this will just be like it kind of slides down the top, where there's some kind of joint from at some point, either the formation of the rock or something humans did to it. Slides differ from slumps in that there's no rotation of the sliding rock on a curved surface. It doesn't curve down. It basically just slides straight down the angle. So now we're going to be talking about flows. So flows is when it's mixed with air or water. You've got, and we're going to be basically talking mostly about the water ones here. So you've got a slurry flow, and a granular flow are the two basic types of flows, and then we're going to go into that and see and specify those even further. A slurry flow is going to be 20 to 40% water, so they're going to be pretty wet in there, all right? And slurry flows are considered water-saturated flows. Granular flows are going to be between 0 and 20% water, so these are going to be flows that are more dry. And these ones, the granular ones, those are the ones where you mix a little bit more air into it to cause the flow, but they both will probably contain some water. It's just that these ones are like pretty saturated. All right, you can see down here the solifluction, not soil fluxion, and I think I had that written wrong on the original blog, so I'm going to hopefully go back and change it before you read it. Solifluction, not soil fluxion. All right, and so that's going to be very slow. You can see the velocity of the movement here. Very slow, but wet. Slow but dry is the creep, okay? You've got debris flows, which are going to be most of your flows that are wet, but they're medium speed. Mud flows are going to be fast, and that's pretty good. That's going to be your fast, wet flows. You've got earth flows, which are related to the debris flows, but dry, grain flow, and then an avalanche. A debris avalanche is going to be a fairly dry, fast-moving event. All right, and you can read about them here. but it's going to go over basically the stuff that I just talked about there. So I'm not going to go too deep into that here, but it is your job to read about these. And that's pretty much it. So that's it for this section. Not a very long one, but I would like you to go and, like I said, and read about these different ones and where they might be in terms of location on Earth.